So the goal of this lesson is to become familiar with a bunch of families of functions. We're studying what are called parent functions, which are just kind of basic functions, and the goal is just to like get familiar with their shapes essentially. So by the end of this note sheet, you're going to draw a bunch of crazy function shapes, and most of this you're going to do on your own. So the ideas here are not that hard. In fact, you already are familiar with them, domain and range. Domain is just the x values of a function. And then range is the y values, of course, right? So you're familiar with this from Algebra 2. So we're going to use this as an opportunity to get a little bit more familiar with our graphing calculator. So I know like right now, I think we're at a lot of different levels with how well we use our graphing calculator. It is a really useful tool. That's why it costs $100. It costed $100 when I was in high school too, which was like 15 years ago at this point. And the reason it costs that much is because it's super useful. So we're going to start super basic. And we're going to use this y equals x function just to make sure we know how to use our calculator so we're on the same page. So to graph a function, you're going to hit the y equals key. And you're going to type in the function. Then you're going to hit the graph key. And it would be super helpful for you if you followed along with me in this video if this is brand new to you. I'm going to show you what it looks like. All right, so I'm going to hit y equals. I'm going to type in just plain old x is my function, and then I'm going to hit graph, and there's the line that I was expecting. Okay, and then what you're going to do on the rest of your note sheet is you're going to graph each function, and you're just going to draw a sketch. And that was, I kind of missed, right? Kind of missed again. There we go, third time's the charm. And your sketches don't have to be super precise, but they should show you the domain and the range of each function. If you want to investigate something a little further, another useful feature, this may be newer, is you can hit the zoom key, and I can hit zoom in, and I can kind of move it around. So let's say I want to look at something over here at x equals -5 and y equals about -1. I can hit enter, and notice my calculator will zoom in and redraw, and that didn't really work because now I can't see my function. I can see it a little bit right down here. So I can move my cursor back over there somewhere, and then I hit enter, and now I can see my function again. Right. So that was zoom, and then zoom in to zoom in, obviously. And then you may run into, especially if you borrow a calculator in the classroom from me, this situation where you're already zoomed in or zoomed out and you can't really see what you're doing. Zoom and then zoom standard is a reset key. So I hit zoom and then 6 to reset. That's super useful to know. Okay, so those are the notes I want you to have as you operate your graphing calculator. Now we're going to write down the domain and the range of this function. And in addition to practicing using our calculator, we're going to introduce a new notation. This is called interval notation. And it's really how we write down intervals in a big boy way, a pre-calculus kind of way. So interval notation is essentially equivalent to your inequality notation. So let's say I wanted to say something like this: x is between a and b. Well, what I would say in interval notation is I would say parentheses a comma b. And these mean the same thing. They're equivalent, right? Now, you guys know something like this means a is less than or equal to x is less than b. The way I write that in interval notation is I use a bracket to show that a is included, and then a parentheses to show that b is not, right? So on a number line, this would be like a filled in circle, something like this. So we'd have open circle for b, and then a closed circle for a. And then let's say I want to say a is just bigger than x, right? Let's write it the other way. X is just greater than or less than a. Let's write it like that. So x is less than a. the way I write that in interval notation is I use now the infinity symbol. And infinity always gets a parentheses. And I would say, in this case, from negative infinity to a, right? So this says x is any number from the smallest number we can possibly think of on the negative side all the way up to a, but not bigger than a. And then we'll do one more example. Let's say I want to say x is greater than or equal to b. Well, b is the smaller number now, so I'm going to start with it, and b is going to get a bracket to go with the or equal to. And then I'm going to say I go from b to positive infinity. So this says every number bigger than b, including b. Okay, so this is how we're going to start to practice writing down our domain and range. And you may find yourself having to kind of translate into that more familiar notation that you're used to. But here's a couple of examples for my linear function. My linear function is all x and all y, right? So I just say from negative infinity to positive infinity for both. Okay, I'm going to graph a couple more examples, right? Just to kind of clarify this notation a little bit more. If you think you'd rather just jump right in and experiment with this notation yourself, feel free to stop watching now and move on. Your next mission is going to be to fill out the rest of the notes using your graphing calculator. So sketch each function and then write the domain and range. Okay, if you're still with me, the next function we're going to consider is 1 over x squared. So find that one, and then we're going to graph it. And I'm going to use the fraction function, which is alpha y equals. Numerator over denominator is what n over d stands for, of course. And then I'm going to type in x squared, and I'm going to hit graph. And notice this one looks crazy. So if we'll zoom in a little bit. Notice it kind of cozies up to x equals 0, but never touches x equals 0. And that makes sense, right? I'm going to draw it. It makes sense that it would never touch x equals 0 because x equals 0 would make the denominator equal to 0. And we know that that's not allowed. That's not the best sketch, but it doesn't have to be, right? We just want to make sure we have a good sense of what the shape is going to be of the graph. And my domain and my range, this is interesting, right? My domain, it's like all x except for 0, right? And the way I write that down is I say x goes from negative infinity to 0, and I use parentheses for both to show that 0 is not included. And then I write u, and the u stands for and, 0 to infinity. Okay, so that is the domain. And the range, well, the range is really y must be strictly bigger than 0, so notice y is always positive, right? So my range is 0 not included, again, to infinity. The last one we're going to include here is the absolute value function, absolute value of x. So you guys may remember this looks like a V-shaped graph, something like that. I want to show you how to graph it. This function lives on the secret math menu. And notice cube root is here too. That's another one of ours. It's ABS, right? So there it is. So when I type it in, I go over to numbers, ABS, and then X, and then I graph, and there's that V shape that I was expecting, right? My domain, X can be whatever it wants, and we see that it goes left and right forever. My range is 0 to infinity, and 0 is included because if I plug in 0 for X, I get 0 for Y. So there's a couple of examples. The key for this will be in the book this time, so your mission now is to finish the rest of them, sketching all your graphs, writing your domain and range, and then there's a little bit of Delta Math practice after that.